Bye.
Down syndrome, or trisomy 21, is a genetic condition associated with a partial or complete copy of the 21st chromosome. Down syndrome is named after a British doctor, John Langdon Down, who first described this condition as Mongolism because the physical features of these individuals were similar to the physical characteristics of people from Blumenbach's Mongolian race. Since the name was inaccurate and pejorative, in the 1970s, the name was changed to Down syndrome. As you're probably well aware, our DNA is like this humongous blueprint of information on how to make a human. Usually this massive document is packaged up nicely into a storage bin called a chromosome. Actually, usually we have 46 chromosomes that we use to neatly organize all our information, depending on how you define organize. Each of the 46 chromosomes is actually part of a pair of chromosomes since you get one from each parent, so 23 pairs. If you wanted to make another human, first you'd have to find someone that feels the same way. And then you both contribute half of your chromosomes, so one from each pair, right? 50-50. Now, what if someone contributes one too many? Say dad contributes 23 and mom contributes 24. Is that possible? Yes. And it's the basis of one of the most common chromosomal disorders, Down syndrome. Someone with Down syndrome has 47 chromosomes instead of 46. Specifically, they have an extra copy of chromosome 21, so instead of 2, they have 3. So Down syndrome is also known as trisomy 21, in other words, 3 chromosome 21s. Alright, so in order to package up half the chromosomes into either a sperm cell or an egg cell, you actually start with a single cell that has 46 chromosomes. Let's just say we're making an egg cell for the mother. I'm just going to show one pair of chromosomes, but remember that all 23 pairs do this. So the process of meiosis starts, which is what produces our sex cells, and the chromosomes replicate. And so now they're sort of shaped like an X. Even though there are 2 copies of DNA here, we still say it's one chromosome since they're hooked together in the middle by this thing called a centromere. Okay, then the cell splits in 2 and pulls apart the paired chromosomes. So in each of these cells, you've now got 23 chromosomes. Now the 2 copies of the chromosome get pulled apart, and the cell splits again, which means 4 cells, each still with 23 chromosomes. Now these are ready to pair up with a sperm cell from dad that has 23 chromosomes as well, totaling the 46 chromosomes, and voila! 9 months down the road, you got yourself a baby. Now, a major risk factor for Down syndrome is maternal age, the age of the mother. Moreover, this condition occurs about once in every 1,500 births where the mother is younger than 20 years old, contrasted to about 1 in 25 births where the mother is older than 45 years old. Now, there are 3 cytogenetic types of Down syndrome: free trisomy 21, Robertsonian translocation, and finally, mosaicism. Free trisomy 21 occurs as a result of a process called non-disjunction and accounts for about 95% of cases. Non-disjunction means the chromosomes don't split apart. If the chromosomes in this first step don't split apart, then one cell ends up with both chromosomes and the other gets none. Then the final result is 2 cells with an extra chromosome and 2 cells missing a chromosome. Non-disjunction can also happen in the second step though, so first step goes great and both cells have a chromosome, but if they don't split apart in the second step, then the final result is 1 cell with an extra chromosome, 1 cell missing a chromosome, and 2 with the right number of chromosomes. Now if a sperm cell combines with any of these that have a duplicate of chromosome 21, then the combined cell will have 1 extra copy of chromosome 21. In other words, 3 chromosome 21s, or trisomy 21. In case you're wondering, the sperm cell could also combine with these cells that have the missing chromosome Apart from non-disjunction, Robertsonian translocation accounts for about 4% of trisomy 21 cases. Translocation, in this case, is a fancy way of saying move from one place to another. So a part of one chromosome moves and switches places with a part from another chromosome. In this case, the long arm of chromosome 21 translocates over to chromosome 14, and you end up with two hybrids, one with both long arms and one with both short arms. This little guy with the short arms carries just a little bit of usually non-essential genetic information and is typically lost by the end of meiosis. So there are a few ways this can go down. First, including the translocated chromosomes, they replicate, and now these could split into one with both normal chromosomes and one with the long guy and short guy. In which case, after splitting again, you'd have two normal cells and two cells with the big guy, since we lost the little guy along the way. So now contribute the other parent's DNA, and you've got two normal cases, and then these two cases called balanced carriers. We say it's balanced because you've got both long arms, and so most of the genes are still here, kind of like a 2-for-1 deal. Okay, now let's say the normal chromosome 14 ends up with the short, and normal chromosome 21 with the long. Now you get two cells with the normal and long arm, and two cells with the normal and short arm, which remember is usually lost. So these ones have one extra chromosome 21, since the long arms carry most of the genetic material for both chromosomes 14 and 21, and these ones are missing chromosomes. Now combine these with the other parents again, and you have trisomy 21 here, and monosomy 21 here, since it's missing a chromosome 21. If this process was switched such that chromosome 14 ended up with the long chromosome first, then you'd ultimately Having an extra chromosome 21 is thought to affect these systems by an overexpression of genes on chromosome 21, since there's an extra copy contributing to gene expression, which changes the development of all the systems just listed. During pregnancy, some screening tests can be done, and certain markers suggest higher risk that a baby might have Down syndrome. Alpha-fetoprotein, or AFP, and unconjugated estriol, or UE3, are on average lower when compared to unaffected pregnancies, and human chorionic gonadotropin, or HCG, as well as inhibin A, are both typically elevated compared to unaffected pregnancies. An imaging test using ultrasound can also be performed, where clinicians look for nucleotranslucency, which is typically performed between the 11th and 14th week of pregnancy. None of these are exact indicators of Down syndrome, however, but they do give valuable information about the overall risk of Down syndrome. Even though there's a long list of complications and hardships for people with Down syndrome, improved medical care has led to a much greater longevity and quality of life. Many individuals with Down syndrome are able to thrive and lead full lives. Alright, as a quick recap, Down syndrome, or trisomy 21, is a genetic condition associated with a partial or complete copy of the 21st chromosome. There are three cytogenetic types of Down syndrome: free trisomy 21, Robertsonian translocation, and mosaicism. Characteristic physical features of individuals with Down syndrome include a flat facial profile, round face, small chin, mouth, and ears, epicanthal folds, short neck, as well as a single transverse palmar crease in the hands, and a gap between the first two toes. Additionally, having an additional chromosome 21 also causes numerous changes in almost all organ systems, including cardiovascular, nervous, gastrointestinal, as well as reproductive systems. Even though there's a long list of complications and hardships for people with Down syndrome, improved medical care has led to much greater longevity and quality of life. Helping current and future clinicians